Okay, question 11. We have a nice 7 marker which is going to involve differentiation and quadratic inequalities. So, Chris claims that for any given value of x, the gradient of the curve y equals 2x cubed add 6x squared minus 12x add 3 is always greater than the gradient of the curve y equals 1 add 60x minus 6x squared. We want to show that Chris is wrong by finding all the values of x for which his claim is not true. Okay, let's first of all define our functions. So let's say let f of x equal 2x cubed add 6x squared minus 12x add 3. And g of x equal 1 add 60x minus 6x squared. Okay, so what do we actually want? Chris is saying that the gradient of f of x is always greater than the gradient of g of x. So, for Chris to be wrong, we want values of x such that the gradient of f of x is less than or equal to the gradient of g of x. So, we want values of x such that the gradient of f, so f dashed of x, is less than or equal to g dashed of x, the gradient of g. So let's differentiate both functions. So f dashed of x is going to be, well, 2x cubed differentiates to 6x squared. 6x squared differentiates to 12x. Minus 12x differentiates to minus 12, and the constant disappears. G dashed of x, well, that's going to be 60 minus 12x. So, our inequality then is now 6x squared add 12x minus 12 is less than or equal to 60 minus 12x. Okay, so this is now a quadratic inequality. We need to first of all get everything on the same side. So we've got 6x squared, and we're adding 12x, so we got 24x, and then subtracting 60, so we get minus 72, and that is less than or equal to 0. Now from here, we have a common factor of 6, So we've got x squared add 4x minus 12 is less than or equal to 0. Okay, so to solve this, we now need to be thinking about the graph of the quadratic. So what we're going to do is set x squared add 4x minus 12 equal to 0. We're going to factorize it to x plus 6 times x minus 2. And that gives us x values of minus 6 and positive 2. So the graph looks something like this, where this point over here is minus 6 and this point over here is 2. Now remember, what we are trying to find is values of x such that the quadratic is less than or equal to 0. So, the parts of the graph that we are interested in, or the part of the graph, is the bit touching and underneath the x-axis. So the values of x are x can be greater than or equal to minus 6 but less than or equal to 2. So those are the values of x for which Chris is wrong. So given that this was sort of a proof question, you would want to finish the question with a statement, something along the lines of, for values of x between minus 6 and 2, the gradient of f of x is less than or equal to the gradient of g of x. So Chris is wrong. Something like that to finish off. Cool.